Hi everyone, today we will start studying one of the NLP techniques, word embeddings. In this video, we will go over the difference between word, token, and type, what is tokenized, the problem with words, what is word embeddings, and what is its main advantage. We will go over an example and how to treat words that can have different meanings, some applications and techniques of word embeddings, and there are some references if you need more information. We need to distinguish between word and token. Word is a single, distinct, meaningful element of speech or writing used with others or sometimes alone to form a sentence and typically shown with a space on either side when written or printed. Token is an individual occurrence of a linguistic unit in speech or writing. Type is the number of distinct words in a text. So most of the time we will use, instead of type, we're going to use number of unique words or number of distinct words. Let's give this example. Cats are also called domestic cats. Cats are small carnivorous mammals of the family Felidae. Domestic cats are often called house cats when kept as indoor pets. Cats are one of the most popular pets in the world. So in this text, we have 25 unique words, but we have 37 tokens. For example, cats appears 6 times, but it's exactly the same word. So it's only one unique word, but we have 6 tokens of the same word. What does it mean when we say tokenize a text? It means to transform this text into unique tokens. When we tokenize a text, every piece of the text will be considered one token. Let's get this text for example. Chris is very good at math. Look at his results in trigonometry and geometry. #math. When we tokenize this text, we have the total number of words of 14, 12 unique words, and 18 tokens. Why do we have 18 tokens? Because the computer cannot understand that punctuation signs and the #mark, for example, are not tokens or should not be tokens. Only words should be tokens, but the computer doesn't know that. So it transforms the punctuation sign in a token. And that makes our data set very noisy. So that's why it's important to text processing our data before we use word embeddings. So what is the problem with words? It seems to work fine when I type my text in my computer or when I talk to Siri or Alexa. They seem to understand what I'm saying. But computers are not naturally familiarized with the words. And that means that they do not understand that the same way that we do. And for Alexa and Siri to understand what we are saying, there are a lot of technology behind it. So if I say something like, I love this movie, the computer probably will not understand that I mean a positive information with that phrase. So how do we transform human language to a computer language and make the computer understand what we want? That's where we start using word embeddings. We have been talking about word embeddings, but we never state what it is. So word embeddings can be a collection of models or techniques for mapping words or phrases into a vector space. The vectors are considered a numerical representation of the words that computers can understand and make calculations with it. The goal is to encode words into vectors that represent their point in this word space. And with that, we can find the distance between two words. We can find the distance between a word and one dimension. We can find similarity between words and in which verb tense this word is, for example. Each dimension is a word space. In this word space, encodes some characteristics or meaning of this word. For example, in our example, we have walking and walked. And one of the dimensions of this vector could be the verb tense. We can apply math in the embedded space, and that's one of the goals of using word embeddings, so we can apply different mathematical techniques and find differences between words. We can find similarities between words, and we can find many other important features using this vector technique. So when we check this word cloud, we can see social media, tweet, share, like, web, follow, blog, effective, instant, wiki, service, information, many words. Are those words completely unrelated? Not really. That's why they are there. Like social media has everything to do with like or tweet because Twitter is one social platform. So we can say, based on the distributional hypothesis, that words that occur in the same context tend to have similar meanings. For example, but and however, they probably occur in the same context, so they can have the same meaning. It is possible to see this correlation of similar meaning in the similar context when we use word embeddings, because the similar words will have similar vectors and they're going to be in the same dimensions. They're going to have the same values in the same dimensions. It is an unsupervised learning algorithm that clusters words according to their context. So that is the important thing with word embeddings. They are able to understand the context that the words occur and cluster them together if they have the same meaning. The use of word embeddings to represent words have many advantages, but the main one is because when we are using a numerical vector to represent a word, mathematical rules apply. And that facilitates the application in many tasks because we can do sum, subtraction, and multiplication of vectors that actually represent words. So we can actually sum two words together and get another one. For example, in this case, we can have woman and we can sum with royal and we're going to have queen. And we can see in this table the dimension. For example, royal, we have king, queen, and princess with the same values. However, boy has a lower value. That's because boy it's not connected to royal. In the same way, when we do the dimension male, we know that king and boy has a higher value than queen and princess because those other two words represent women or female. When we have age, the age dimension, king and queen will have a higher value than princess and boy because we know that usually princess and boy are connected with children that have lower age than the king and the queen. Let's go over another example. In the left side, we have the words. In the middle, we have the word embedding table. And in the right side, we have the visualization of the word embeddings in 2D. Let's take table 1 first. We have 4 words there: dog, puppy, cat, and houses. And we have 7 dimensions. We know that dog, puppy, and cat have some correlation among them, but the computer doesn't know. So we have to train the computer to understand the correlation, and it is able to do it by checking the context that those words occur. And we can see in dimension 1 that dog, puppy, and cat have similar values, and houses have another value that it's a negative value, and it's not correlated to the other values. So we can say that dimension 1 could be animal, and that's why dog, puppy, and cat have a positive value and a similar value, and houses has a negative value because it's not an animal. And we can also see in the visualization in this graph that puppy, dog, and cat are stick together and houses are a little bit far away. In the second table, we have those words: man, woman, king, and queen. And we can see that, for example, dimension 1 could be people because man, woman, king, and queen are all persons like people. But if we check dimension number 4, we will see that man and king have a positive value while women and queen have a negative value. So dimension 4 could mean the gender male. And we can see the same pattern when we check the graph in the right side. We can see that men and women are almost together and king and queen are almost together. As we saw in the last example, if we add women plus royal, we will have queen. We know that some words have different meanings in different contexts. What the computer does in that case? Let's take, for example, Apple. We know that Apple is a fruit, but it's also the company of Steve Jobs. So Apple can be the food or the company. Let's take two phrases as example. The first one is related to the food. The which with tartness, it's often combined with sweeter juices such as apple or grape. The second one, Apple is rumored to be working on a smartwatch, which may be called an iWatch. So the word apple has two semantic classics in this case, food and organization. So we can see that the phrases have different contexts. So some algorithms will be able to capture that and give you different vectors for each apple word. So the apple as a food will have one vector and the apple as an organization will have another vector. One example of an algorithm that does that is Elmo. Others will not be able to understand why the same word, occurs in different contexts and will give you the exactly same vector. So that's one thing that we have to keep in mind when using word embeddings, because sometimes we will get a similar word to apple as banana, but in that case we were talking about the company. So the computer again, the computer will not understand what actually we want to say until we tell it that we want to say that. We already know that NLP has many applications. Almost everything related to artificial intelligence and the way that computer understand human language or texts are related to natural language processing. So some applications of word embedding could be the sentiment analysis. The computer alone would never be able to understand that a word has a meaning or a sentiment behind it. For example, good is a word that it's related to a good sentiment, and bad is a word related to a bad sentiment. So using word embeddings, we are able to classify some movie reviews or book reviews or purchases reviews into three categories or more, like bad, neutral, or good. And with that, we can build recommendation systems that will see that you bought something and it has something similar and will recommend to you as a next purchases or a next movie to watch. We can also say that the Google Translator uses word embeddings, because you give Google a word and it will compute the vector of that word, will find a similar word in another language and give it to you as a translation. Spell checks and information retrieval are also only able because of word embeddings. There are many techniques that can be used to generate word embeddings. Some of them are bag of words, TF-IDF, word to vec, paragraph to vec, glove, Elmo, fast text, and we're going to cover some of them in this class. The first one will be bag of words, and bag of words is known to be the simplest method to generate word embeddings. It has many advantages, and we're going to see that different techniques suits better different tasks. So keep in mind when performing your work, you're going to have to choose between some of the techniques or use them together and analyze which one works best for the task that you were performing. That's all for today. If you need any more information, you can check the references or send us a message. See you next time. Bye.